Okay, let's get started. So this is a computer network forensics class. We're going to meet here every Friday from 7:30 to 10:15, almost 3 hours in this room. This is the first time I use this room actually. So I'm Zemin Zhao. I am a research professor here at the computer science department. I do all kinds of research on security, privacy, and also forensics. So I will explain later, security and forensics are highly related. So they are basically the two sides of the same coin. And my office is 4th floor, this building, and my office hour is right after the class. I have 2 hours office hours. Or if you want to schedule a meeting with me during the semester, just shoot me an email. So I have been teaching network security class here. Anyone took network security class with me? Oh, you? Oh. Okay. So this class compared to network security is a little bit more application oriented. So network security is already very application oriented, but I gave a lot of background there. We discussed a lot of theories there, but for this class, it's very, very application oriented, and I'm trying to make it a little bit lightweight. Network security class was a very heavy class, so we had so many course projects, but this one we're trying to do in-class exercise, so you don't have to spend too much time after class hours. You do everything, almost everything here. Besides the exercise you do here, you only need to finish several assignments and a paper report and also a course project. There is no other homework. So we have 2 TAs for this class, and they're not here today. In this class, since we have a lot of in-class exercise, we're going to use laptops and some special software, and the TAs will wear the mobile card to this classroom every week after this one. So that's why we have 2 TAs, and I will post their office hours later. So before I start to introduce what is forensics and what is computer forensics, I want to explain a little bit more about the IA concentration program here at ASU. So no matter you are computer science student or computer engineering student, you can have this IA concentration. And we also offer IA concentration to master and also PhD students. By the way, I'm recording all my video, the lectures, so we're putting them on YouTube, but I'm not streaming yet. So don't curse. So IA concentration, the minimum requirement is you need to take those 5 security classes. Information assurance, system security, data and information security, network security, and this forensics class. So you don't have to take those classes in this order, but usually information assurance gives you the background of everything, the background knowledge of security, forensics, privacy, and all other courses can help you. Each of them can help you understand other courses. They are very related. If you go to the graduate level, we have other classes like applied cryptography, information assurance, and security, which is a graduate level of that 400 class. And we also have software security, advanced computer network security. And this semester, Dr. Yang is offering a similar class called binary analysis. And I believe he will put his videos online too. So if you are interested in the malware forensics part of this class, you can take a look at that class. So binary analysis obviously is part of software security. So binary code is just software. But because there is no source code, you only have the dumped binary code. It requires you to have a different skill set to analyze binary code. So there is no requirement for you to take any classes before actually. Even though on the website we list 310, but actually we're not using any advanced algorithms in this class. But like I said, this is a very application-oriented class. You need background in operating system, how software works, how hard disks works. You need the background everywhere. But I'm trying to make this class very self-contained. I'm trying to give you the background in this class, so you don't need any prior class. So at ASU, we have this very big information assurance center, and also information assurance education is very important for us. So NSA and DHS designated ASU as a national center of academic excellence in information assurance and education. And this class is part of the curriculum. Like I said, information assurance is like the background, and all other 4 classes can give you a sense what the real-world security, real-world forensics is about. And security and forensics, also including privacy, they all come together. So here at ASU, we have a center called the Center for Cybersecurity and Digital Forensics. So you see, even the title has both words, security and forensics. And I'm affiliated with this center, and also IEEE, which is the largest scholar association. They have a very good journal, a top journal called IEEE Transactions on Information Forensics and Security. So you can see security and forensics, they always come together. So what you are going to learn in this class, I'm teaching it as forensics, but what a lot of techniques you are learning, they can be used for attacks. They can use for defense. So they are also security. So if you want, how to classify them is sometimes just based on the purpose you are using, not the technique itself. The technique are very similar, or they are just the same. So that's why, because how many of you took information assurance or any security class before? Okay, so most of you took some kind of security class. But I still want to remind you as a goal of computer security, so it will be better for you to understand the difference between security and forensics and how they are related. So in security, there are some basic goals defenders trying to achieve. And the first one is called confidentiality. So basically, it's about to prevent, detect, or deter improper disclosure of information. That's probably the first goal of computer security as a defenders. Obviously, if you are an attacker, you are trying to breach vulnerabilities. You are trying to break confidentiality. And the second part is called integrity. Prevent, detect, deter improper modification of information. So we're not talking about the integrity of person, not someone's character. We're talking about the integrity of data, the integrity of information, and those kind of data information can also be code. And the third one is called availability. Prevent, detect, deter improper denial of access to services provided by some system. For you to better understand this, I will give you some examples. So everyone in this class, you will take exams and you will get a final score. So you are not supposed to know the score of your classmates unless they gave it to you. So that score, someone else's score, is confidential. You're not supposed to know that. So that is confidentiality about. And integrity is about you are not supposed to change your final score or someone else's final score in the system. You cannot tamper the integrity of that. And availability means your score and all the lecture notes, all the materials in this class, they should always be available on Blackboard, so you can have access. So that is about availability. So in addition to those confidentiality, integrity, availability, usually we call it CIA, in addition to that, there are some other goals we are trying to achieve as a defender in security. I will only mention two here. One is called authenticity. Basically, it's assurance that a message, transaction, or other information is from the actual source it claims to be from. And the non-repudiation means the assurance that someone cannot deny something, such as the receipt of a message or the authenticity of a statement or contract. I will use the same classroom example to help you understand this. So obviously, authenticity means you cannot pretend as a TA to send an email to your classmates. So actually, I have a very funny story to tell you. This happened like 2 years ago, probably 2006. There was a graduate level computer security class. And in that class, the assignment, the course project was to develop some exploits to compromise a target system. And all the students are using the same target system, using different accounts to access that system, try to compromise, and try to go to the next level. So one of the students in that class sent out an email, register an email account using the professor's first name and last name, and send out an email to some students, probably not all. Anna, were you in that class? Do you know?
No, but I've heard the story.
Okay. So send out the email to some students and ask for the keys, to ask for the exploits. So obviously, he breaks the authenticity there. He was trying to be the professor. So obviously, because the emails come from a fake email, a fake name, the professor's first name, last name, it's very hard to tell who is the actual guy behind this thing. So what the professor did is, of course, some students forwarded this message to the professor. Then what the professor did was he developed an exploit which can leave some trace, can leave who execute this exploit on the machine. Then ask one student to send this exploit to that student. So that student get this code. He didn't check what this code does. He didn't remove those Trojans in that code. So he executed the code in the cloud server, so which left a trace, exposed his identity. So don't cheat in a security class, okay? So non-repudiation means if the TA send you a message, he cannot pretend that he didn't send it. Or the same case, that student, when he sent out that email, there is a way the professor could find his identity. So basically, those are the goals of security. Those are not all the goals. Especially, security right now is a huge area. It's not like 20 years ago. Security is very new. People do hacking for fun. Right now, security is really a big thing. Cybercrime is really a big thing. So the goal of forensics is basically defined as relating to the use of scientific knowledge or method in solving crimes. And you can see that any attempt to break the previous security goals we mentioned, they could be considered as a crime. Of course, I'm not the one to judge if it's crime or not, but this is basically the definition of forensics. And there are several similar definitions in books about forensics, but what I'm going to teach in this class will probably go beyond this a little bit. I'm going to teach something relatively new, like car forensics. So sometimes it is not necessarily related to some kind of crime, but probably more like accidents. But why I'm going to teach car forensics in a computer forensic class, because cars, they're just basically connected computers. One car, probably they have like 20 or 30 computers. Each of them is called an ECU, a very small computing unit. So they are connected together. So you can see that there are a lot of security problems. First, each computer, they have system security problems. They are running software, so they have software security problems. Since they are connected, there are network security problems. And the drivers, there are a lot of drivers, passengers, so there could be usable security problems and also privacy issues there too. So that's why I will cover a little bit car forensics here. That is actually one of the areas I'm working on, but usually I call it car security, not car forensics. So the two TAs in this class, they are both working on this direction. So different from security, forensic analysis usually happened after the computer network is compromised. And we are trying to, in forensics, we try to acquire data, even if the original owner doesn't want to leak that data. Or they can intentionally delete those data or information from the hard disk or anywhere, any kind of storage media. So this is when you're doing this kind of forensics, you actually breach the security goal confidentiality. The original owner doesn't want you to do so. So the objective of this class is to provide a basic and also comprehensive understanding of computer forensics and corresponding techniques and tools. There are some forensics principles we need to understand. Most of them come from law. I'm not really expert in those areas, so I will briefly mention about those things. And we were mostly focusing on forensic techniques. And there are a lot of tools we are going to use this class. Some of them are real-world tools used by FBI and other law enforcement agencies. One of the tools we are going to use is called FTK. We pay top dollars to get those tools. We will touch some relevant topics, cybercrime, legal issues. And like I said, I want you to have a lot of hands-on experience in this class. I'm trying to let you to do the exercise in this class. And also I want to introduce you to reading research papers. So also I plan to invite 2 speakers from government and industry to talk about real-world security and forensics. So there will be 2 midterms, and my plan is after each of the midterm, there will be an invited speaker from government and industry. So we are going to, some of the bullets we are going to talk about, computer basics, file system, how hard disk works, how computer boots, how we can extract forensic evidence from those kind of information. We need to understand how operating system works, how memory system works for memory forensics, how network works for network forensics, email forensics, something like that. We need to understand the principles of forensics, just called a rule of evidence, and a lot of tools we are going to talk about, and cybercrime analysis. So books. There are a lot of books on digital forensics, and there are even more books on cybersecurity. So my lecture kind of follows this book, Computer Forensics and Investigation. But this book is kind of old. They talk about very traditional forensics, like disk forensics, file forensics. But I'm adding a lot of things like memory forensics, mobile forensics, car forensics here, which are not covered, or also malware forensics, which are not covered in this book. And some of them may not be considered traditional forensics by this book. So there is no requirement for you to purchase any book. But if you want to have a solid background on this, I still think this book is the one you should go for. It have several chapters on legal issues. It's actually, those kind of materials is not easy to find in other technical books. And or other books we have in our lab, you can see a lot of them has the forensics words there. So you can find a lot of books online too. So this class, I'm going to, usually I will give a lecture at the beginning for each class. And there will be one topic each week. And I videotape everything, put them online, and post the links on Blackboard. And after the lecture, usually we will have 2 paper presentations on the topic that day. So I will give you some background of that area. Then by paper presentation, you can get a feeling what is the state of art in that area. Then we will do some hands-on project in-class exercise on that topic. So I noticed that there are several laptops here in this classroom, but that's not enough actually. That's why we have another mobile cart with probably 40 or 35 laptops, but it's not enough for everyone. That's why we need you to form groups. So two students will form one group, and you will stay in this group in the semester. You will do all the exercises together, do all the assignments. There will be 3 assignments together, and also the projects together. So wisely choose your teammate. And because there are a lot of in-class exercise, I need you to be here every week. Even though I will post the video online, I need you to be here every week. I know the class is kind of early. It's 7:30 in the morning, right? Okay. So to give you a feeling what we are going to do in those in-class exercise, we are going to do something basic first, create disk images using all kinds of tools, tools like DD, or commercial tools like FTK, and use FTK to locate the MBR of a disk and try to dump the code, disassemble the code of MBR, try to understand how the computer boots, understand the layout of the volume, and use FTK to discover the physical layout of a file system based on VBR. If you don't know the meaning of those words, doesn't matter. We're going to discuss those in weeks. And I also designed some malware forensics challenges. Basically, I'm trying to crack some software. So it's a little bit different skill set you need there. But we are going to go over all of those. I call them malware forensics, but if you call it software hacking or whatsoever, that's basically the same thing. We are also going to do image forensics, mobile forensics. I remember there is one email forensics. So I think at this moment I have probably 10 or 11 exercises ready for you. Okay. So assignments. So the assignments are very similar to those in-class exercise. So the in-class exercise, we're not going to grade it. But the assignments, we are going to grade it. So each group will take a hard disk home, and you can use the desktops on the second floor to finish the task and compile a report. The reason you have to use the desktops there is because the special software you need, basically FTK. There is no free version of FTK available. The project will be also a group-based project. So you are going to develop a program that pertains to each of the 3 tasks of a forensic process: acquisition, authentication, and analysis. It's not a very heavy project. I will post it probably 2 months from now. It's not very heavy. You can choose any language you like, you are comfortable with to do this project. Since I want to introduce you to paper reading, also another reason I want to do this is because we are meeting here every Friday for almost 3 weeks. There's no way I keep talking 3 weeks and you don't fall asleep. So what I plan to do is try to, by the way, this will be my last semester here at SU, so I try to make this class more interesting so everyone can have some fun. And this class is not very heavy, like I said. So each graduate student or honor student who wants to do an honors contract, you have to present a paper. It will be 25 minutes paper presentation and question and answers. I will send out guidelines before your presentation. And for everyone else, you have to at least finish a paper report. You need to choose one paper, read the paper, write a report. But for undergraduate students, if you volunteer to do a paper presentation, you can receive some extra points. Okay, this is why you're here. Great. So there will be 3 exams, 2 midterm, 1 final. Class assignments, 3 assignments, 25%. Class project, the programming project, 14%. Paper presentation and paper report will be 8%. And I expect you to be here for the in-class exercise, so that's like 13% of the final grade. So I'm very generous in grading. If you took my network security class, you should know. Usually I gave like around 30% A or A+. And like I said, since this is my last semester here at ASU, it's not my best interest to fail anyone, okay? But if you don't show up, I mean, I cannot help you, okay? So some of the tools and softwares we are going to use, the first one is called FTK. This is the one widely used by law enforcement and also including FBI. Another tool we're going to use is called ProDiscover, and we are going to give you some hard disks. For the malware analysis part, the malware forensics part, we're going to use a software called IDA Pro. This is basically the best disassembly software available. There is a free version for it. The professional version is like very, very expensive, like thousands bucks or probably more than 10K. But there is a free version for it. So we are going to use a free version. Which means you can also use it at home to practice. And if you are interested in this area, you can take a software security class in the future, and also the binary analysis class. So to me, for malware forensics, it's not really included in the traditional forensics class, but this is the most interesting part of forensics. I will basically put everything on Blackboard. I already put the syllabus there, but I think I'm still missing some information there, so I'm going to keep updating. And all the lectures I will record and post online. And sometimes I will post some reading materials just for you to better understand the topic and also this field. You don't have to read them. They will not be included in the exams. But like I said, the class is already very lightweight. So you have enough time to read those materials. I'm going to use a system called a grade scope to grade all the exams. You don't need to do anything at this moment. I'm mentioning this because if you get an email from Gradescope, just don't be surprised. So I don't think I need to emphasize integrity too much. Like I said, I have no intention to fail anyone, but you have to come here and you don't cheat. If you don't come here or if you cheat, I cannot help you. Okay, so since we are going to do a lot of group activities in the semester, so why don't you just talk with your neighbors and try to form a team? And we will start the next part of the lecture in 20 minutes. Talk to each other, talk to each other.